Okay, so this is going to be your first video for this particular chapter. We're going to give this a try. This is going to be a longer video because the notes are a little bit on the longer side. Okay, so in this rounded rectangle that you're seeing at the top of your page are the 7 exponent rules that hopefully you already know. But if you don't, I'm going to go ahead and write the answers in here so that we can then use them to solve some problems. So the first one is if you're multiplying the same bases, you keep the same base and you add the exponents. Okay. And then for number 2, it's very similar. If you're dividing same bases, you keep the same base and you subtract the exponents. And it's the top one minus the bottom one. For number 3, if you have an exponent being raised to another exponent, those just get multiplied. And this also works if you have multiple bases within a set of parentheses. Then the rule is multiply each of the exponents over here. Anything except for 0 is going to equal, when it's raised to the 0 power, is going to equal 1. So again, this only works when x does not equal 0. All right, a negative exponent that's in the numerator, right, becomes positive by moving into the denominator. Okay, and then likewise over here, when you have a negative exponent in the denominator, it becomes positive by moving into the numerator. Okay, so those 7 rules are what you need to memorize. And we're going to use them right now to try to solve these problems. So there are 10 different examples. Here goes, and in multiple parts. Okay, so for question A, because I have different bases here, right? I have some x's along with some y's. I'm going to use the rule where I keep the same base and I add the exponents. That's the case for the x's. And then for the y's, again, keep the same base and I add the exponents. And you may not think that there's 1 on this particular y, but there is. It's an invisible 1. And if you add those up, you get 6. Okay, for question B, this whole numerator ends up being a 1. And then this negative exponent is not allowed to remain negative. It must become positive by moving up. So this whole answer is x to the 5th. On this one, this exponent here is going to be sort of distributed, for lack of a better word, to everything inside. And then when you simplify that, we'll end up with 9x squared, and then this becomes y to the 4th. Over here, this negative exponent means that this entire set of parentheses is going to move into the denominator. And notice now the exponent is positive. And now I'm going to simplify by distributing that exponent, so 2 to the 3rd and x to the 3rd, giving me 1 over, and this right here, guys, is 8, not 6. Okay, if you're not sure why, it's because it's 2 times 2 times 2. Okay, on question E, or part E, the only thing that has a negative exponent on this, in this problem, is the x, not the 2. So the 2 remains up top in the numerator. This is what moves into the denominator with a positive exponent. Okay, so here I'm going to move everything, all of this, into the denominator and make this exponent positive. And then I'm going to distribute that exponent to everything inside. So I end up with 9x to the 6th y squared. All right, here. Now, this can be confusing for some. I am multiplying the same bases, and the rule is keep the same base and then add the exponents. Okay, it does not become 9 to the 10th. Okay, it is not that. Okay, make sure you understand you're keeping the same base. Okay, same thing here. Multiplying same bases, you keep the same base and you add the exponents. Okay, now there's another way you could do that problem. You could move this one into the denominator, which would look like this. And then you could simplify that, right? So if you think about this, this means 1, 2, 3, 4 5s. And this means 1 5, and one of them cancels out. And you're left with 5 to the third. All right, and sort of the same situation here. We could subtract. We could say 4 and then subtract the exponents, which is 4 to the negative 5, which is 1 over 4 to the 5th. Or another option on this problem is the top is 3 4s, and the bottom is 8 4s. 1, 2, 3, 4, 5. That's 8. And then I can cancel 3 of them, and you can see I get the exact same answer of 5 4s on the bottom. All right, continuing. Okay, so we're on example 2 now. These get a little bit more difficult. Okay, so I'm going to take care of these parentheses down here first. So the top remains the same. There's my 4. This becomes m to the 6th. And then I'm going to reduce. So 4 goes into 25 times. And then 6 of these m's cancel out. And I'm left with an answer of 5m to the 4th. On B, same situation. I'm going to make sure everything in the parentheses gets some of that 3. So here's my numerator. On the denominator, I have 5 to the 3rd and then n to the 12th. And then just a reminder, 15 can be rewritten as 3 times 5. And the only reason I'm doing that is so you can see how easy it is to cancel. So this 5 up top is going to cancel with one of these 5s down below, with 5 squared. And then 9 of these n's cancel out, which leaves me, grand total when I'm all done, a 3 on the top, and then a 5 squared and an n cubed on the bottom. Okay, I've got some negative exponents to deal with here. So step 1, I want to get rid of the parentheses. Okay, then this and only this is going to move down. So now I have 5y squared along with y to the 6th. And then I'm going to put these together. I'm going to combine them. And the rule is if you multiply same bases, keep the same base, add the exponents. Okay, moving on. I'm going to start this problem by moving this up to get rid of the negative exponent. So now I have u and a positive 7 and this 10 down below. So then the negative 5 with the 10 cancels. And then these two combine to be u to the 9th. And my whole answer here ends up being u to the 9th over negative 2. Okay, I'm going to deal with this negative exponent first, which means on the top, I'm going to have 4c to the negative 3. On the bottom, I have a negative 4, and then c to the negative 20th, and d to the negative 16th, right? Those, it got multiplied. All right, so now I get to move some stuff around. Okay, I'm going to leave the 4s out in front alone just for a second. This moves into the denominator and becomes a positive 3. This moves into the numerator and becomes a positive 20. This moves into the numerator and becomes a positive 16. And now that I have no negative exponents, I'm much more comfortable reducing. So this cancels, leaving me a negative 1 on the bottom. 3 of these C's cancel, leaving me with 17 C's. And nothing happens to those except that they are part of the answer. Okay, I'm going to deal with this sort of the same way. I'm going to make sure that everything inside these parentheses have been distributed with that negative 1 exponent. So I'm going to have 2 to the negative 1, f to the positive 5, and g to the negative 1. And then my next step is moving everything that has a negative exponent. So I want you to see that the 10 and the f to the 5th don't move. They don't have negative exponents, so they're just going to stay exactly where they are. So I'm going to move this, I'm going to move that, and I'm going to move this. Now I just need to combine and simplify. So here, that multiplies to be 20. The f to the 5th doesn't combine or cancel with anything. And then this g cancels with one of those g's, leaving me with 5 g's on the bottom. All right. Next, let's talk about fractional exponents, which this may be the first time you've seen these. So a fractional exponent looks like this, right? Where the exponent literally is a fraction. It can be rewritten, as you can see, in that rounded rectangle, where the denominator ends up being the root. You can see it here and here. And the numerator ends up being the power. Okay, so again, you can rewrite these either way. I just want to make sure that you're comfortable with it. So let's try these. All right, so the top number is the power, bottom number is the root. So this ends up being the cube root of x squared. Okay, here again, the bottom number is the root. So this is going to be a square root. And the top number ends up being the power. So you could write it like this. You could completely eliminate that exponent because raising something to the first doesn't change it. Okay, so here, bottom number is the root. Top number is the exponent. All right, and just a reminder, that exponent can either be inside the radical or it can be outside the radical. Your choice. They are equivalent. All right, so this is the power. This is the root. All right, again, top number is the power. Bottom number is the root. This one I'm going to have a 7 out in front. Top number is the power. Bottom number is the root. Okay, and then down here, for example, 4, we're going to do that the exact same way. Top number is the power. Bottom number is the root. Okay, here I've got a 3x. Top number is the power, because I don't see 1. Bottom number is the root. Keep in mind there's always an invisible 2 in there. This one I'm going to have a 5 out in front. And then I'm going to have x cubed y to the 4th. All to the 1/4 power. Okay, so now we're at example 5, and it's saying use exponent rules to evaluate the left-hand side to find the value of a. Okay, so we're starting to solve some equations. I'm going to use the rules over here so that I can figure out what a is. So the rule is, if I have the same bases being divided, I keep that same base, and I subtract the exponents. So 6/5 minus 1 is the same thing as 6/5 fifths minus 5 fifths, which is x to the 1/5. So a is 1/5. All right, on this next one, if you're multiplying same bases, you keep the same base and you add the exponents. So 3/4 plus 1/2 is the same thing as 3/4 plus 2/4. So this equals x to the 5/4. That's what a is. A is 5/4. And then here, when you have an exponent raised to another exponent, those get multiplied. 2/3 times 3/2 is 1. And since that equals x to the a is 1. Okay, now here it says important exponents to remember. Just these are the ones that come up the most often. If you see x to the 1/2, that's the same thing as the square root of x. And if you see x to the 1/3, that is the cube root of x. Okay, so down here, when it says 25 to the 1/2, that's the same thing as, hey, what's the square root of 25? Which is 5. All right, and this is saying, hey, what's the cube root of 64? That's just 4. And this is saying, hey, what's the 5th root of 32? That's just 2. Okay, and then you can kind of put those things together. So here, the cube root of 64 is 4, and when I square that, I get 16. All right, and then here, inside these parentheses, the square root of 25 is 5. When I raise that to the 3rd, that's 125. And then 4 to the 3rd is 64. And then when I raise that to the 1/2, that's the same thing as saying, hey, what's the square root of 64? Which is 8. All right, so these are saying expressed in simplest radical form. So this, when I do 27 to the 1/3 power, that's just 3. And then in radical form, this right here is telling me to take the cube root of the stuff inside. Okay, so sort of the same situation here. This is the cube root, and then this is raising it to the 4th. Okay, so the cube root of 125 is 5. And then when I raise that to the 4th power, that's 625. Okay, and then when I do that here, the cube root of x to the 3rd is x, and I'm raising it to the 4th power. Okay, and then this last one, for this example, this is saying, hey, what's the square root of 4, which is 2? Raising that to the 5th power is 32. And then same thing over here, the square root of x squared is x to the 5th power is x to the 5th. All right, and then for example 7, it says write it in simplest radical form and in simplest exponential form. Okay. All right, let's take a look at this first one. I'm going to put the stuff that's in the parentheses together first. So that becomes h to the -6. And then I'm going to multiply these things together. So now I have h to the -24/15. Now I need to make that positive. You're not allowed to have negative exponents. So now I have 1 over h to the 24/15. Okay, that's simplest exponential form. That's exponential form. And then for radical form, I'm going to have this as the 15th root of h to the 24th. I'm going to leave it like that. All right, so now I'm going to do this the same way. I'm going to simplify this first, which becomes, when I add those exponents, -1. Then all of this moves up. And now I have it in simplest rational form or exponential form. And then changing that to a radical, that's the 4th root of y. Okay, and then for this one, I'm going to clean this up inside just a little bit. Adding those, I get just an m, so that's simplest radical form. And switching it to the other form, that would be m to the 1/4. All right, and then moving on. We're on example 8. Okay, so this, if I write it with an exponent that is a fraction, is this. And then this one is this. And then if I use that rule, where you multiply same bases, you keep the same base and add the exponents, that just gives me 1. Same situation going on over here. This would be 7 to the 1/5 times 7 to the 1/4. And if I add those two fractions, they both have a denominator of 20. This would be 4, this would be 5, 9/20. Okay, same situation here. This is 5 to the 6/5. This one is 5 to the 4/5. Adding those up, that is 10/5, or 2, and 5 squared is 25. This is 6 to the 5/3. This is 6 to the 1/2. Adding those up, the denominator is going to be 6. What is that? 10 and 3, 13. All right. And then this is where we start actually, well, not start, but we continue to solve equations. We did this earlier in this lesson. So I'm going to simplify this and write this as a fraction. So x to the 2/5, and this is x to the 1/3. And then I just have to subtract whatever 2/5 minus 1/3 is, which is 6/15 minus 5/15. So 1/15. A is 1/15. All right, so I'm going to write this as x to the 1st times x to the 5/3. Multiplying same bases, you keep the same base and add. So that's 8/3. So A is 8/3. All right, this is x to the 3/5. This down below is x to the 1/5. And then because you are dividing bases that are the same, you subtract the exponents. So 3/5 minus 1/5 is 2/5. A is 2/5. Oh, I'm not sure what happened there. All right, we have x to the 5/3 times x to the 1/3. Here I'm going to be adding those exponents, which is 6/3 or 2. A is 2. All right, and I know this has been a long lesson, but here we go. All right, so I'm going to take care of that negative exponent first. I'm going to write this as 8y to the 24th over x to the 3rd. And then this is all being raised to the 1/3. So everything inside is going to get raised to the 1/3. So 8 to the 1/3 is 2. These exponents get multiplied, so that's 8. And these exponents also get multiplied, which is just going to be an x. I'm going to do this similarly. I'm going to take care of this negative exponent first. Okay, and then I'm actually going to deal with this a little differently than I have in the past. So I'm going to make this exponent positive by making the stuff that's inside change locations. All right, and then each thing inside those parentheses, I'm going to take the square root of it and then raise it to the 3rd power. So on the top, I'm going to get x to the 9th. On the bottom, the square root of 4 is 2 to the 3rd power is 8. And then multiplying these together, that's y to the 6th. All right, so this one I'm going to make this positive by rewriting it like this. And if you remember, raising something to the 1/2 is the same thing as taking the square root of it. So this becomes 8xy to the 5th. Here I'm going to take care of these two negative exponents first. And then everything is going to get some of the exponent. The 4th root of 81 is 3. 16 times 1/4 is 4. And 28 times 1/4 is 7. I'm going to move this up. And then this is the same thing as 13 over 26, right? Power on top, root on the bottom. And that does reduce to 1/2. Here I'm going to move this into the denominator so that I have d squared over d to the 3rd. This simplifies to be 1 over d, which then ends up being 1 over d to the 1/3. Top is 1, the bottom is d to the 1/3. I'm going to move this up, n to the 7th over n to the 5th. All of this still to the 5/8. I'm going to simplify this stuff, which becomes n squared to the 5/8. And then those multiply together to be n to the 10/8. And then lastly, this I'm going to move up. That simplifies to be m to the 3rd. Multiplying those together, we get m to the 5th.